All right. Yeah, it's been a little while since I did a stream or anything, or recording, but I have been working on stuff in the meantime. So I'm just gonna go through kind of what I've been doing, and this is more for just keeping up to date. I've been due to write a blog post a bit more about my current progress. Let's see what's happening. So I added a few bits. Got lighting working. Oh, that was a compute test. It just writing read write texture. You can now define inside. Let's get this a bit bigger. And there's one in tests. Okay, so inside here, got compute test. So this is a dispatch compute like pass that can go in a render graph, and you can write to a texture and you can tell it which texture that is. This compute texture 3D I think is created in here as well. So you can create textures, unordered access, shader resource, and that's being written to. So that's quite a handy thing to be able to have. I also added these point lights with a couple of different lighting equations. So it's got this is Cook, Torrance, Specular, and just Lambert's diffuse. I got some spotlights. I made these like little kind of visualizations. So the idea all along was to be able to make this tool that you could make these like little graphic demos or ideas and sketch them out and do live coding. So these are a couple of ones which are quite nice to look at. Um, so these ones came out pretty well, I think. What I need to be able to do is save out some parameters for each of the different demos. So like when you go to it, it makes sense because like I could do something like if I go to the geometry primitives, they're tiny now, and then if I position the camera correctly for like if you want to look at these as a preview, something like that would be suitable. Then if I go to point lights, well, point lights looks all right actually, but spotlights. Oh, here's a directional lights one. These little cubes, they look nice. The chamfer box. I went through the trouble of making nice normals for them. So yeah, these ones have I made these. I posted some of these on Instagram. Maybe those ones. It looks quite nice closer up. I did them a bit smaller, but now I'm starting to think that they would look better closer up. But the point of these is that it's not just the demo. It's like it's not just to make the demo. These are testing directional lights, point lights, and then I got these obviously the basic ones, which I was using before, so I've been through those quite a lot. This is new, draw indirect, so it doesn't really look that impressive at the moment, but basically this is a draw. It draws the teapot by execute indirect, and the buffer is generated from indirect arguments. So let's have a look. I had been meaning to reorganize these samples. So we create a buffer with indirect arguments in it, and that's basically just one draw call set of information. And then that's passed to execute indirect. Obviously, in the future, that'll be bolstered by being able to generate that buffer from a compute shader or something like that. So just noticing these normals look maybe a little bit weird on the teapot's spout. Maybe I'm not. Maybe I'm incorrect. But So yeah, I got lighting, I got draw in direct, and the last thing I was really working on in the stream was this thing, which is bindless materials. So all of these things are generated by, well, it's a bindless draw calls. I think in the long run, the indirect draws will also play a part in that. But the next thing I was going to start thinking about was to um, start getting some lights involved as well, and then getting normal maps on there. So what I wanted to do, because I hadn't done it yet, is write some code which does the tangent space normal maps for these meshes, because I have those materials and it's been a little while since I did this. So let me have a look on the to-do list. So to do, I was working in progress with my executing direct. At the moment, I've just got the basic kind of first part of it working. I've got some tasks that are like accumulating for PMFX that are sort of cropping up from different bits. I've got some stuff about the examples there. I was saying I want to tidy them up, make it a bit easier to kind of navigate and jump around the project. But this one, transform normals with the world space matrix and construct tangent space, is kind of what I'm going to do now. So, I mean, I suppose I could do it in here, but I was going to set up a sample, maybe with all of the primitives, which I can just use to debug and make sure each of the meshes tangents are working correctly. So that's what I'm going to do. Wrong one. Primitives. So geometry primitives. I can use that, basically that same setup function, and I'm going to put them in, but I'm going to change the shader. So the first one's going to be so it's geometry primitives. In space, normal maps. For the time being, I'm not going to have the rotate, and we'll just keep it like that. So, because all I have at the moment is these primitives that I've generated myself. So I just want to just to debug them and make sure the tangents are correct. I have my vertex format is quite fat at the moment. It does have tangents and bitangents in there, which maybe I'll generate in the shader. I hadn't really thought about it. I think pretty much most of them it's just using a cross product of the tangent and the normal to generate that. But for the time being, that's kind of, I'm just going to get this hooked in. And this is why I wanted to sort out these demos, because all of these functions getting registered and just kind of a little bit messy. System funcs. Oh no, you don't have that. This is kind of nice because it doesn't have to register any any functions. Tangent space normal maps. Still building. Missing demo function, tangent space normal maps. Right one. Oh, it is there. Right. Here we go. So they're basically all of these guys. I want to apply a texture to them, which means I do need maybe a bit of a different setup function. Set up draw material. We need load material. I need different info per draw call. I actually don't. I only need kind of a single material. Load material. Oh, I should have really done this before starting a stream. It's kind of boring, probably. But that's just how it is. Okay, yeah. So I had these ones. Let's see. Angled tiled floor. These ones look cool, actually. I wanted just something fairly extreme, and also just to make sure to orientate them correctly. The tangent space of the normal map itself, I need to make sure that that's all right. So let's have a go. The first time I've actually done this, but already using a pre-made set of geometry primitives, tangent space normal maps. Then I go set up tangent space normal maps, and that's going to be similar. Is it set up function? I don't need those anymore. Okay, so we need a device. We need a. It's basically similar to that. So I'm going to do two setup functions. One's going to load the normal maps, and one's going to load material or some textures. And then we're just going to pass those through in the render function. So we might have to make our own render function. And that's one place where the render functions are getting a bit messy. I think what I'm going to do is go for one file per example and try and organize it like that. And then everything's kind of in one place. So we spawn a meowing cat. Right, what are you doing? No. Right, so basically the same as in the draw function. I don't want to load a whole material. I just want the normal map to begin with, a texture. So these did load texture component. That's fine, and we need a PMFX actually in the textures, and then we spawn a texture entity. I mean, maybe I'll load a few just you know, to have some different ones to check. We can do that. We need PMFX to put it on the shader heap. Okay, so tangent space normal maps. It's not really the grid I want. I wanted this one. Textures PBR antique grey 1. Windows. Okay. Just going for the one. Load a single texture and make a component, an entity to keep hold of it. Then we can do set up tangent space normal maps. I want to improve this. That's next on my list actually. Just as there's so many examples now, it's getting a bit messy. So I'm missing a function. Now it's working. Right. So these render functions now animate textures. Some animate functions, which there's a bunch of stuff just bunged into the lib file. Render meshes, bindless material, draw meshes indirect. There's the indirect, execute indirect call from earlier. I don't need that anymore. Render meshes pipeline, render meshes pipeline colored, push constants texture. See this one, what it's assuming is each entity has a texture instance, which is not quite what I want. Hmm. This is where it start like the setup functions and the update functions and things like that make more sense. It's when it becomes rendering function combinations. There's quite a lot of different ways of doing things now, and there's a kind of lot of slightly duplicated code. So it's this pipeline. There's a grid and there's meshes. This is going to be called mesh debug tangent space. Mesh debug tangent space normals. I think it can have the same push constants texture because it's just one. The same shader, but we just need a different render function to basically render what does it do. And then yeah, these ones are going to move around, so they're going to be together with the example, or if they are shared and generic, then hopefully it'll be a bit clearer. So instead of basically we push a world matrix per entity, but then we push the texture won't be part of this. So we'll have a mesh component, we'll have textures, texture query. This is where I have to do queries as a tuple. Queries. And this is a tuple, and we're going to have two lots. Query mesh component, and just query with a texture. It's a texture component. It's fine. It can be the texture component. This always happens. Render meshes. Render scene meshes. Sure. Used to debug. Meshes. It doesn't have to be a constant normal map, but So this one, it binds that at a 16 byte offset. It should be okay. I think it's going to let me do this, but this is feeling a bit cumbersome. So we've got texture in texture query. So then we have get us a v index unwrap as u32 usrv. And it needs to be passed like that. That doesn't have a texture. So we're just going to bind the first texture, and there is only one, but first texture. But if we load a couple, once it kind of works, then be able to. And this needs registering, though, you see, and now there's these things, updates, setups. These are all quite fine. Batches, and then it becomes render function. There's becomes quite a lot of them, and they're becoming a little bit messy, I think. Push constants texture, so it goes, it slots in here, but I suppose, you know, oops, oh my god, what the hell, how do I get out of this? I don't even know. Don't even know how that happened. It's stupid. So this is a render func, and it's got basically similar to this, but this is getting tiring now. Render meshes, debug tangent state space. We take that. The query itself is a tuple, and that is a query of texture. That's how I do queries, I think, in other places. Yep. Is this gonna work? No. Queries, texture component, will matrix, and mesh component. Mesh, debug, tangent space normals. I think once these are a bit more organized, it will make sense, and like having the duplicated ones will make sense. But for the time being, it's getting a bit messy. Well, messy for my liking, anyway. I mean, I have seen horrific things in the past in other people's code, so. But, you know, it's taken like 20 minutes to just set up a new sample. Not really, not ideal. And now I'm like, I don't even know what file was it in. Right, this one, render, yeah, there's something up with this. Render meshes, debug tangent space normal. It's a tuple. Ah, it's this. Missing. Come on. Build failed still. Arguments to the function are incorrect. Ah, this is texture component. Now we're building. Right, okay, well, let's see. They haven't got wireframe, but debug.pmfx. So mesh push constants texture. That isn't the pipeline we should be using, and we shouldn't be rendering them as just. Go back in here. Right, okay. Oh, here we go. Look. Perfect. I had to change it and change it back because I don't know why. Anyway, so these are obviously not it's not the right thing, but it's a starting point. And also, so what we need now is to do the normal transformation. So after a little bit of effort, it did eventually, you know, I got there, and we have this now. Debug HLSL shader, which is what it's here for. So we have checkerboard was a thing. Mesh lit. What's our outputs now? VS output material. We're only outputting a normal, not TBN. And like these things, there's loads of these building up now as well. I mean, in the long run, VS Mesh material is the thing we want. Kind of like one of these, but it's texture PD. Let's see, for instance. Oh, there's just so many things. In the end, I'll get them rotating as well. That's kind of part of the objective. Right, so VS Mesh. This one is instanced. So I don't know what I'm running out of names to call stuff. VS Mesh full. It's going to be called. Input normal is not just input normal. VS output material. For the time being, I'm going to make a new thing, and push constants texture. Oh my god, there's just so much stuff, so much to think about. Right, VS output VS output lit, which isn't quite the same as material. For the moment, well, we do care about text, chord. We got normal, which here the float threes. I'm not sure if these all want to be float fours. If they have to be four, float four aligned. Let's just go with this. We'll add tangent and we'll add tell you what, no. I don't care about color. This is just for now. I feel like I should be moving these into separate files. But I keep saying that and I keep not doing it. So 3, 4. So we've got normal, tangent, bitangent, and I'm going to go 4. These are going to be all 4. So there's no, we're using more interpolator space. I'm going to get it working, and then I'm going to see if I can knock them down to 3. So one reason for this is historically, or well, not historically, but for a while, like everything I've done, or things I was working on, I don't like having these spaces like this. I was always making constant buffers, everything 4 bytes or 4 float 4s, and like packing things in. All matrices 4x4, but you can save a lot of bandwidth by having vertex buffers that aren't, all float 4 types. So now I'm sort of seeing where it's applicable or not. Sometimes, it makes sense to pack things together, and if you've got light position, you could pack the radius in the W. But sometimes it's a bit more readable to have structs where you have a float 3 and a float, and the actual named members are what they actually are. So here again, more experiments. This math HLSL actually was something I added, and that's probably where the tangent space stuff might go. It's just generic code that I've used elsewhere that I'm porting across. It's got some stuff like lighting equations. This Chebyshev normalize should go in there actually. UV gradient, that kind of stuff. Right. So we've got VS Mesh lit, I'm going to call it. Because the other ones, they're not really lit. VS output lit. Get a world matrix in. We transform that. So we don't have a color. Right. So we need to now tangent space. Transform these guys. The normal, the bitangent. Actually, well, hold up. The input normal of float 4 as well. No. And the other thing is, I don't know if I really want the bitangent in the mesh format. It makes sense to save that if you can do it by just the cross product. at the expense of the extra ALU. We'll just put a 1 in there. Tangent, 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 bitangent, and bitangent. But I did like having bitangents just coming through from the modeling package, and then you don't have that whole thing where you're like, oh, are these the right way around, and flipping them and stuff. So sometimes the convenience or having them correct from what's been authored is also handy. Obviously the best would be to have both. PS mesh material, ray marching, cube map, checkerboard. Right, so we're gonna go. It's actually not gonna do any lighting. I mean, oh, there's a whole shader. This is misaligned. Oh, it's just that. It's fine. Right. PS mesh, debug, tangent, space, normals. We have VS output lit, right? So, well, the first thing we do, we're going to be doing this basically the same shader because that's what we're already using. We have draw indices X. We have albedo. We don't need that. I'm just going to change this just so when I get it working we know it's using the right one. And I need to make a new shader. PS mesh debug tangent space normals. Reload complete, and the shader's compiled. Save all. Okay. So we've got mesh debug. Mesh debug tangent space. I mean, I'm gonna just call it tangent space because it's less less text. Mesh debug tangent space. VS mesh lit. Was that? PS mesh debug tangent space. We have view constants, draw constants, and all of that same stuff. This is all still compiling. Let's add a new, let's change that mesh debug tangent space normals. And I'm going to change those names while I'm here just to make it a bit awkward. That means in here we're going to go with mesh debug tangent space. It's going to be a missing a function. Samplers cannot be mixed with descriptors. Uh, well, that wasn't bad. What's that? Like, that's about 45 mins. That was the first crash. So, I suppose I've not been doing anything too difficult, really. We go on there. Samplers. Right, so now something's messed up with my thing, which is annoying. Mesh debug tangent space. librs. Render meshes debug tangent space. Render meshes debug tangent space. That's that, that's that. Render meshes debug tangent space. What it was before actually was different. I think I'm copying the wrong shader. So push constants texture. Mesh push constants texture. We need a static sampler. That's all the same as mesh debug, so we can just inherit it. Okay, let's go. Clear. Build and run. Oh, right. Yes, okay, so that's what I did. I changed the shader and I added red. So just wanted to make sure it was all piped in, which it is. So now I've got normals. Let's have a look. Let's go in the shader. How exciting. It's working. It's working. Right. We can output constant color equals, well, let's go with RGB. Input.normal. Okay. So there are normals. They're not correctly rotated though, because green is here. Green should really be directly up. I keep holding Windows key. I don't need to hold it. I'm used to holding Alt and then rotating, which I don't have to do. So here's just the pure normals. We've got these inside normals. That's kind of how they look. You know, they look normally to me. Rotating the cone looks a bit weird actually. So there might be some particular weirdness, but that's kind of what this is for. Yeah, I already did a fair amount of work working on the normals of these, but having the tangent space and proper lighting is going to help to sort of iron out any lasting or last minute problems. I'm just going to get rid of that. Just less difficult. So, right, rotate. So the things I've got to do is rotate the normals with respect to the world matrix. And then I've got to transform the tangent space normals. These ones look a bit weird as well, actually, which, I mean, the cone looks totally wrong. And it doesn't look very smooth either, which is annoying. or alarming. Ah, cones. And actually, that means that these are that is a cone, I think, and so are they. Pyramids, cones. The tetrahedron looks a bit weird, right, but it's not too bad. The capsule looks alright. Capsule looks okay. Okay, so what do I have to do? Let's have a look at the tangents. Right. Well, I don't even know if that's good or bad. Sometimes they can look like this. I was hoping them to be a bit smoother. Not gonna lie. So let's see. First things first. Let's get them. Well, actually, let's have a look at the bitangent. I think some of them I haven't really thought about in great detail, and some of them might be completely missing or wrong. Like when I was adding them, I was debugging the normals, but I wasn't really paying. I was kind of quickly adding the tangents. So okay, that means in this mesh lit shader, instead of just passing these through, we need the world matrix, the 3x3 world matrix, which I think I was doing elsewhere. I always forget about the best way to do. And here we construct one kind of individually and then transpose it to make an inverse transform. We don't want the inverse. We just want this on the rot. I'm going to do it this way first, just so I get it working, and then it might be okay to cast just directly into it. But so if we mull, no, wrong we do it, and then rot with input normal, mull rot with input tangent, mull rot with input bitangent. That's failed, of course. Invrot, sorry. Rot. Well, that doesn't look right. It kind of looks cool, like cell shaded. Look at this, cell shaded helix, but that's certainly not correct. So we mull. We do have scaling in there. Right, but so if we normalize each vec one of these, it should be enough. We could normalize the results. Doesn't really matter. Okay, so I can't really tell, like, we need to rotate them now. So I'm going to add the update function to make these guys rotate. rotate meshes. And, well, I think the diagonal's throwing me off a little bit. But they do look like reasonably nice colours. Not just like nice, as in like they're nice colours. They are actually genuinely, you know, got a nice sort of hue to them. So they're kind of looking all right. One thing I can do, I'm just going to do this for forever, really. So if I put them flat, then, you know, we should see green. Green is a bit more up. And yeah, I think, you know, looking at it, the cones, the octahedron doesn't look very good either. Teapot looks fine. The inside of the this tube one, this looks wrong. It's like that. The normals on that need inverting because blue is this way. So yeah, there's a bunch of stuff on there on the normals to sort out and fix. So like, but they're rotating. The transformation is fine. I'm just gonna see if I can do float. Can I do something like this? Float 3x3 from WM. Is that valid? A cat, is that cast? I always forget about like how the casts work now. Too many elements. Too many elements. There's no way to truncate it. I wonder if can we do this way. So I know this one, GLSL doesn't do sort of C style casting. Can we in HLSL? Because, you know, I don't care about GLSL anymore. Ooh. Obviously, we haven't normalized them. Could normalize the mull. The wrong thing. I don't know what would be better. Doesn't really matter. It's the same. It's 3 normalizers. That has worked. Well, this looks nicer, so that's for the start. Which means, can I do that? No, it's not a cast. The other one, what was it for? Imrot, and then we transpose it. I'll leave that for now. So now I've got the rotating normals correctly rotating. And then we're going to apply normal maps to them by doing a TBN transform. I'm trying to remember off the top of my head how we do it. So let's see if I can remember. I do have old code which does this, obviously, and then there's the internet which has all of the information. I've actually been using Bing Bing chat with ChatGPT. It's all right. I tried to get it to help me to do an Aura Nayar diffuse, and it didn't work, and I couldn't really spot the bugs in it. So, yeah, it's like, I don't know, it's kind of a bit weird. It'll give you code that, like, with confidence, but then you have to have skill to be able to figure out if that's right or wrong. So, where are we now? Debug, debug, debug. I need to organize myself. I'm going to take a long, hard look at myself and organize myself right. So we construct a matrix. It's a 3 by, it must be 3 by 3, right? We've got a 3 by 3 TBN matrix. And N, that makes sense. So T, the tangent, is the right axis. Right, so we go TBN. TBN 0 equals input dot tangent. And so this is where I'm saying I don't need like the fourth component of the tangent. TB by tangent. Good job they called it something like this. N normal in Z, which makes sense. You know, the normal is the Z axis, the right axis, and the up axis. So right up at whatever you want to call them, forward normal dot XYZ. We've already normalized it in the fragment did we? Yes, we normalized them in the fragment shader. So we're saving pixel shader ALU. We don't need to normalize. I've got to always want to save my ALU. Right, so this isn't albedo. This is tangent space TS normal, right? Tangent space normal. It's gonna whinge, isn't it? I'm just gonna initialize this to black. How many times have you ever done that? 0.0, 0.0. Just like a madman filling it out. Right. It's not doing anything, but that can go. And that's just my debug. Right, so TS normal, it's in 0 to 1. So we need to bias this into -1 to 1 range. How many times have you done this? Times 0. No, it's times 2 minus 1. The other way is times 0.5 plus 0.5. So that's TS normal, scale and bias, right? And then let's have a look at TS normal. It's going to look a bit different to what it did before. It's stronger blue, right? Stronger blue. Stronger blue. That's about it, really. There's some blacks in there. I think. Then we're going to look at this and go, oh no, the green is upwards. That's green. But this is looking all right, actually. This is looking all right. Maybe I've got the right ones. So on the last one or a couple of streams ago, I was talking about I bought these normal maps and so on. Or this whole PBR set, and there's different. Well, there's Unity, Unreal, or Blender. Was the main ones. So I got the Blender ones, but that was OpenGL, and I'm using Direct3D. But I am using the old right-handed coordinate system. So, to this one, what is it? Yeah, this one, right-handed. That's the one I've always used. Even though it probably doesn't make sense. But that looks correct to me. Unless these are, they could be inset, where then they need flipping. because that could be the underside. Depends if they're inwards or outwards. And that's why I wanted to get some different normal maps, and I'll have a look. And if these are wrong, then I don't want to do extra arithmetic, really, to correct the normal maps. I'd like the data to come in and just be nice. The other thing is upside down. I did flip the UVs though as well. So that's another thing. Like the Y could be flipped, but I flipped the normals to basically. So looking at a texture the right way up in Photoshop or whatever you use, when you load that in and render that on a model, it looks the right way up. Which means the UVs are kind of I did flip all the Y's basically, so that's fine. I can do a batch job and flip all the normals, or get the other ones if I can figure out how to get access to that. So we've got tangents, we've got bitangents. What do we do then? We've got the tangent space, and we've got the normal. So I need to now multiply this, transform this normal. TS normal. I only want the float 3 of it as well, you know. That's fine. Float 3. Normal. And it equals, so we mul TBN by this TS normal. We could normalize it. Everything should be normalized already. Right, so now our green is pointing downwards. I mean, let's have a look. Cylinder. At the moment, cylinder looks the best, right? What about sphere? Spheres do look like that. I think I'm going to have to... Oh, actually, I've got this now. I added this camera. I can't move it. The delta time thing. Right, it's fine. Now I can get a little bit around the place. What I could do is sorting that out, actually. Let's see what we've got. Time, pause, delta time. We have these bumps. What are they supposed to be? What was it called? Antique grate. Antique grate. Let's have a look. Antique grate 1. And then we've got these. Here we go. Antique grate 1 BL. Right. This is the original. Okay, so it's little guys are inward dents, right? So these little things are going inwards, and so these should be green, I think, and these should be pointing down, right? So the green's kind of in the bottom, and they should be pointing down. So I think that's kind of correct. Green at the bottom, black at the top. If we're just thinking about the let's just do the green basically, and we can do times 0.5 plus 0.5 to get a bit more, because round the back, let's see. Oh, my camera. Add one. Shift makes you move faster. I need one that makes you move slower. I mean, this guy, look. These tangents are all over the shop. And these inside bits. I need a bit more control. And I'll be able to pause time and still moves the camera. Right, so M. It is quite hard to tell. So the way it should be is that these are dints inside. It's got a rim on it. And this rim's going to be pointing upwards. So we've got some green. Let's just go and just isolate completely the green channel. I'm using the sphere because I think the sphere normals are fine. We could check the cube maybe as well. The cube might be a good one to check. I'm just going to basically multiply this so I'm only isolating a single axis. Oh. So this is green in that. How are we getting green down the bottom? No, I don't want that. Input normal. And now I need this. Right. I'm kind of not that keen on the top. Do spheres always look like that? Like there should be, surely that should be green. Is it minus green? Like here, this is pointing upwards. Mate, I haven't even got. Right, look. Well, that's wrong, isn't it? The sphere's not pointing. Right, this looks rubbish. Like, this is terrible. Normals. I mean, this is pointing straight up. Box. But that is not correct. So the tangent space is wrong, basically. I'm just going to have a look at the actual input normal. Oh, that's much better, right? And that's actually a decent reference. Because we should be getting close to this. And that means my input normals are good for the sphere and the cube at least. And the cylinder. The cylinder looks good. Which means then the tangent or the bitangents aren't good. And they're what's stuffing me up. So let's have a look. Let's look where it goes wrong. tangent's got that in there. And that. So the tangents have got these pinch in there, which obviously is then severely deforming the normal when we transform it. That's fine. And right, this one's all over the shop, but in some ways the kind of the detail in there. Pause delta time, and I can't use the camera. I'm going to sort that out now, and I'm also going to add a little I'm going to have to close that because I need to edit the edit code in the client, but I'm going to add this because that was making it not very easy to debug. So smooth delta paused bool delta scaled by time, scaled by time scale, or maybe paused. Going to be raw delta. Raw. So there's a raw delta, which is going to be the same. Just going to update that. If time delta is paused, so time raw delta equals regular time. Delta accumulated smooth delta history. Also, if I just quickly run, oops, did a hash on that. I think this was, it was causing a divide by 0. Mate, this is so long. Right. So our little rim on the outside, inside, just double checking that while I wait for this excessive compile times. But what I wanted to look at was this pause. FPS goes to a large number because calculating this FPS based on the delta time. FPS, smooth delta. We'll go on raw delta. Might be a bit more spiky, but we go on that. Then we got where did the other one go? lib.rs. I've got a problem. This some of the camera code and this kind of core functionalities in another plugin, but that's causing a crash with Bevy where the resources aren't any longer have matching IDs. So I might have to move this code anyway back into the client because it doesn't work with hot reloading basically. Camera fly, move delta, speed, speed is just normal. Boost speed. Let control speed. That's going to be, maybe we go for a quarter. Smooth, not smooth delta. Raw delta. And so we do a boost or control. You won't be able to have both. Doesn't make sense to have both. L, fine control. Modifiers. Right, so we can do speed boost, or if we've got control down, that's sys key. It is. Come on. Curtail. I think it is. Mate. Just annoying. IntelliSense. Garbage. Well, not IntelliSense. It's Rust Analyzer, but I am too reliant on it. So then hopefully that works. Just fixing up a few bits of stuff while I'm here. And now I can cry in despair at my tangents being crap. Here we go. Okay, I've got small movement. Let's pause. Oh, I can still move. Look at that. Control movement. Look how close I can get. Right. What are the tangents supposed to be then? I mean, I've got all of these primitives to sort them out for as well. Is this what they are? That's the transformed one. I mean, that is there. That is blue. That should be red. Let's see. If we're looking at blue, I'm going to orientate myself. What I really need is a little axis debug widget where it's just so I can use that as a marker. But I know the input normal is pretty clean. On X, Y, Z. Right. And that has blue pointing at me, which means this right-handed coordinate system, Z is pointing towards, right is right, and Y is up. So X is right, basically, which means red on this side, blue here. And then if we go to the normal, we've got blue. It looks like red is pointing the... Oh, no, because they're inset. So that would be pointing red. And that would be pointing there. So they look kind of vaguely correct. Like this one particularly, this face looks good. Like that actually looks correct. Hold on. How's that even happening? It shouldn't look like that, should it? Like the different faces. That shouldn't be blue. Let's see then. Right, like actually the reference normal is the way to go. It's a little bit What I really need is some other meshes that are different. And I will draw them. See, that should be purple, and that one should be coming blue. And why did it do that? It shouldn't reset the scene. Oh, hold on, actually, that's not a bad idea though. Just going for. Let's get rid of this. Right. Blue. Like, this is fine, this blue face. This one, that's totally wrong. Totally wrong. Do you know what? I asked ChatGPT to do the cube, and it's been a never-ending, bottomless pit of mistakes. It did the UVs wrong. It basically got the vertices right. That was it. That was the only thing it got right. The rest of it was a slow, as I used it, because at first I'm only rendering just the verts. So I'm like, cool, it gave me a cube. And then it's like, then you just got to end up going through the whole thing. So ChatGPT can fuck off. ChatGPT is not replacing me. Right, so we've got Z. So right, that's it. That's all right to know actually. And this one, so this one we should be seeing red. This one we should be seeing. That one should be black. Let's have a look at the reference normal. Black. Cool. So the front and the back faces are actually decent. And then the sides, they're just totally wrong. Like this one should be, that one should be black, shouldn't it, actually? Potentially. In order to debug it properly, because we've got a couple of black faces, we're going to have to now go into tangent space, well, not, what would we call this? Bias mode? Bias mode. Bias mode. Right, okay. Oh, look at them. Does it just make you feel relaxed? Look at these. So this is what I've been looking at for a while. And I've been like, these are perfect. Perfect normals. But they kind of are. The normals aren't bad. Except for the cone. Liar. I'm going to have to sort him out. It's not even smooth. I'm pretty sure I had a smooth cone. I've had trouble with the cones before. They can be annoying because of the tip. I mean, I don't have to get all of the primitives correct, but I swear I had these ones actually were correct, and I flipped them because I thought they weren't. So anyway, I think the best ones to go for is the cube and the sphere, like they're our ground truth in a way. Now I've got my camera control. Look how controlled it is. So much control. Oh yeah, right. So I'll stop messing around now. Okay, so we're biasing normals to look at what the colors are, and so far the cube has one correct face. One correct face out of 6, because it's actually a hexagohedron. Oh no, I need this. I need this. And the isolating channel, I don't need it, but I'll leave that in. Oh, sorry, that's the same. Same code. So now we use the transformed normal. Right. Okay, transformed normal. And that looks like basically exactly like we would expect. The inner bottom is a lip which points upwards. The inner right, they're pointing rightwards, but that's the side to the left. And the other one's slightly darker, they're pointing that way, right? So this one should match the color on this side. This is totally weird. I don't know how it's getting that. This color, that looks correct. So we can confirm front and back are correct. This one's wrong. But these are nice colors actually. I quite like this. I don't know if I can make it. It's quite nice. Quite nice colors. But quite nice colors isn't what we want. We want the correct colors. Top. So let's have a look. Top and side. These guys. Get the normal reference back on. We should be seeing soft greens there, and they've taken us into grey, the grey world. And the bottom, oh, they're all terrible, right? But again, quite nice. I quite like these. Oh, now I've got control. These are like good color scheme inspos. I'm just gonna take a little screenshot of these. Getting in paint.net. Spun the canvas. Right, get a new one. Right, that one was cool. Let's see. Was this? These are all pretty cool, actually. I didn't do Alt. You know what? Got that one. Ah, this one, yeah. Complicated, upside down. Uh, uh, this one. Do we have more? That was not my favourite of the lot, but I'll save it. Sometimes it's just good to have a bit of reference and stuff, ideas. And what was the other one? Was it the bottom? That was the top. We had the side. This guy. I think I got that. That was all of them. There was. So what else? There are 4 bad ones. It's like wrapping around. Okay. So let's see. Let's get the cube working, and let's see if I can go from there. So in the world of the cube, first I can go into the primitives code. Cube vertices. These are even a thing. So the normal is 0, 0, 1, and that's Z is pointing towards us. This is the front face. Then we've got tangent is pointing to the right, +1, which is this direction, and our bitangent is upwards. Now, obviously, we can cross product these together. Well, these two to get the bitangent, but for now, I'm sticking with just putting them in there. I'll just be back 1 second. Right, mate. 'Only 4 p.m. I'm finished work now, so I'm just lounging around for a few weeks before starting a new job. Um, but it feels later. I was doing some coding before this, then live stream, then knackering. Anyway, so the back face, our normal is -1, and our tangent is -1 with the same bitangent. And let's check if that looks correct. So we know plus, so we should be red going in this direction. And yes, these are insets. So that should point that direction. And that we should be purpley green this direction. And green going upwards. And actually, what I never looked at was, what's the bottom colour? Bottom colour. It's that purpley colour, right? Purpley colour. And so these ones, these are kind of purpley, right? Purpley, purpley. Right, I think they're cool. Got 2 out of 4. And I'm pretty sure I actually changed those. I'm not letting ChatGPT take any credit for this. It's not having it like it did it wrong. So what should we work on first? Let's go on the right face. Right face, front face, back face. First two, the right face. So the normal is pointing in 1 in the red. The tangent is not 1. The tangent should be, well, in our coordinate system, what's that? That's -z in the right face. -z. -z. Y is still up in this one. So Y is still up and the normal. Now, annoyingly, this code, what I need to do. Hold up. I'm going to have to just take, oh no, damn, I could have sorted that out. Right, this is code in the core engine. I'm moving it into dev, where I can add all of the same functions. Let's run this again. It's the same code, but it's in a plugin, so I can edit it in real time. Then, I know. Hold up, it is a simple change. I've done this a few times. It's a reasonable strategy. It should be. That does exist, mate. No. Oh, I did it in the wrong one. That's fine. It's dev. And this is the one that needs changing to hotline or S. Come on. Come on. Right, and then I can go into primitives in the demos. Let's get the old... Oh, actually, the plane mesh and the billboards we should check first because, well, the billboards are kind of special case. Right, well, I want to get these reset to axis aligned. I'm just going to reload the code. Done. Right, okay. That's wrong though, right? If you actually look at it, it should be red and it should be the other way. So the tangent here, if the normal's pointing towards us, the tangent is minus Z this way. But really, I think it needs to be flipped. But the reason why I moved all of that code is we can go... Do you know what? Well, for the time being, let's get rid of all of this. Let's just do... create dev, create cube mesh. We're just going to have one mesh there. One single mesh. Right. But that's wrong. Wrong, correct. So, was it the right... Actually, maybe... Cube vertices. Cube vertices. Right, so we were at back face. No, we're at the right face. And I decided the tangent is going to be minus Z. But really, for some reason, the tangent should be the other way. Let's flip the Z and see if that fixes it. Right. So there, what do we have? We've got green on the bottom, which is pointing us. We have purple pointing downwards. And purple pointing downwards. I think this edge and this edge are the wrong way around, which is awkward. That should be red and that should be kind of greeny, yeah, with that on top and purple coming down. Maybe I need a better a better normal map to have a look at. But the kind of the basis of it is correct. It's not going to be flipping the... Let's see about this one then. The left face. Right, left. Yep. Right, so the left face, normal. -1 in the red. Which means we go 1 in there. Still on the same bitangent of up. It's building. Right, here we go. That's gone red. Ah, oh, sorry. It should be... This one should be minus, then. Minus, 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 minus. And then I feel like it's going to be the case of the... So we've got green pointing up, we've got kind of purpley pointing down. But then the main one is like, this face should be kind of purpley, and this face should be kind of yellowy, right? Where's our yellowy bit? Our yellowy bit and a purpley bit are the opposite way. And that, I think this could be to do with the handiness in the map itself, which is weird because, like, I think this one doesn't need to flip anything. Dark green, red. Let's have a look at this one. Red, dark green, green. It's these ones. These need flipping. Now, if you flip your bitangent, I think that's going to flip the y-axis, right? Which, the y-axis is fine, yeah. Now they look like they're sticking out, which, that's okay. It's just like this is not ideal. Ah, is that to do with the UVs, right? The UVs of these sides need flipping in the x-axis. So if I flip the UVs, then that might work. Which this is going to be the best way to do it. I flipped them all, actually, in terms of trying to make things look correct. But obviously it doesn't really matter. These normal maps matter more. But let's go with the top face. Top face, normal is pointing up towards us in the y-axis. So I think our tangent well, firstly, our bitangent is not y. Our bitangent is z. And I think our tangent is red, like plus. Certainly for the... Well, Oh, I must have missed one of the corners. Top face. Yeah, that one's still wrong. Right, so we have green. I think it looks indented. It looks like it's the wrong way. Green should be the primary color. These are wrong. But that could be down to the UVs. So let's get the bottom roughly sorted now. So the tangent is minus, the normal is -1 in the y-axis, which is as expected. Our tangent and bitangent, now, this is weird. I don't know what this should be. Like, what should your orientation be looking at this? Should you be this way round, or should you be this way round? So anyway, the tangent, bitangent, if we go 0 and 1, and I mean, this is kind of worth going through the UVs as well. So it's ended up green. Which one do I flip? The tangent? Let's do tangent is -1 with the same bitangent. I don't even know. I don't really know what they're supposed to be. So, well, that's not correct. Go minus in both of these. Minus, minus, minus. What should we be looking at? Purpley colour, right? There we go, purpley. Right, so we've got green, we've got normal map, we've got red, yellow, dark green, purpley. Okay, so this one was all correct, and the tangent space is all correct. This one, what we're looking at is this slight purpley to point down, red, that's yellow, and purple. Yeah, okay, I can see. Yellow, purple. They should be the other way around. Can that be flipped? Can that be flipped? So the right face, or the X UV, or the U, right face, text coord, flip the U. So all the ones become zeros. All the zeros become ones. And does this flip it? Oh. Is that correct? Are these going to swap? They have done. So now we get purple on the ridge on the inside pointing that way. So when we look at it, it's kind of like this angle, right? This is pointing this way, this lip. This lip is pointing the other way. Purple is pointing down. Green is pointing up. That's it. That's the correct tangent space for that. So this was correct already, right? Red on that lip, green on that, green pointing up, purple pointing down. Done. This guy, where you at? purple pointing that way. Right, it's what was this? Left face, flip the text towards. I mean, to be honest, I arbitrarily flipped these with respect to some textures I had. I think it's fine just switching them this way to make the tangent space correct. So now we have a lip. Let's see, on this corner, this lip would point this way, so it's purpley. This one lip points the other direction, so it is yellow. Green pointing upwards and purple pointing downwards. Kind of like a magic eye. If you look at it, it sort of flips, embosses. I mean, I could put some lighting. Maybe I should do that. Like, obviously, I'll get them working a bit first, then I'll get lighting on. I'll double check it. Right. So now this one, this is where I think it all goes a bit weird, and also quite arbitrary. I didn't know how I was flipping. So the starters, the purpley ones and the yellow ones are pointing in the wrong direction. So the top face, is there a flip we can do? That should be red, that should be purple. In the x-axis or the u-axis, I think they seem correct. It's actually the y-axis, and I don't know if that can that be addressed by flipping simply the tangent, or is it a UV flip? Well, it wasn't that. Okay, so that's not correct. Can this tangent flip it? This one doesn't feel right to me. Bill fails. Where's that? It's one. So the tangent space now, that's not right. That is not right. Because the U chords aren't right. Ah, hold on. But if you do both, no. No, right. Let's go. This is basically graphics programming. Just flipping ones. Flipping ones, flipping the axis, swapping axis. Right, we got an edge pointing. Right, just let me check I'm orientated correctly. At this corner, and it's quite easy to see, obviously, this inner edge should be red. This inner edge should be purple, and that one should be yellow. So what we're looking at is the flip. The flip of the y-axis here in the UV top face. And I mean, at this point, I did orientate the UVs based on an image that looked correct. And once you get to the top and bottom, you're like, well, which way should it be? I don't know. You know, it doesn't really matter. So let's flip the V in the text coord. And then So now the inner edge points purple. This one's pointing yellow. This one is pointing red. And this one is pointing green. So that's correct now. So is that almost a full sweep? It's just the bottom. Let's have a look at what we're seeing. Once you get the base color right, this needs to be flipped in both the U and the V, I think, and that's going to sort it out. Zero, 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 one, one, one. Come on. Okay, what do we have? This one points red, this one points green. Oh, no. The red and the green are correct. But the... Oh, no. That is correct. Because that's pointing the opposite way. And that's the inner edge pointing there. Right, there we go. A tangent space cube. Let's go for resume time delta. I'm not keen about this top rotation. Shouldn't be changing like that. Like, I'm looking at this and I'm like, cool, right? Is that right? I mean, yeah. But the top and the bottom should not be. Should not be rotating like that. They should be more constant. But our faces. So is it like one of them you shouldn't rotate? Oh god, I haven't really thought about this ever in this much detail before, you know. And you can do this, slow it down. Okay. That face turns to yellow. This one. That doesn't feel right. Where were we? Blue. This should come round to... No. That's not right. The faces alternate. Like their identity positions are correct. So that means maybe the oh god, if I have to transform them again, well, I suppose this is the whole point of it. So it goes red to yellow, always. Red to yellow, or pink, purpley, kind of purple, red, orange, yellow. The normal transform's correct, I'm pretty certain. Is it taking so long? And why are you not? Oh, get rid of that. So this one goes red to yellow, blur. But now we've got a blue face. Then we get a red face. The TBN matrix transform, I think, is a problem. Let's have a look at input tangent. Input tangent, it's like similar. Blue, no. These are the ones that look wrong then. Like at the point they get here, they should be the same, I think. What we're saying. Sure, we have to rotate them, right? And that's why this one's going mad. Right, well, what I'm going to have to do... This is my old shaders. It's not cheating if you look at your own code. I'm just going to check what I do. It got like, because what I want to figure out is it my code? Is it my tangents? Or is it my code? And... So we do VS main extrude, pre-skin, VS main. So we transform them, normal tangent and bitangent. We do. I mean, I can't guarantee that they were correct either. They went to this length of detail to make sure that the tangent space was spot on. Shame I don't have a mesh. So yeah, basically it does the same thing. Takes a 3x3 matrix, normalizes it. Then we go T, but transform TS, normalize, TBN. Ah. T. These are different. So it should be the same, but it goes, it's the other way around. And this one becomes TBN. But the thing is that it still doesn't feel correct. I mean, especially on the top. What am I even rendering there? Tangent. It's like every other face, you know? The tangents are like, oh, is that because two of them are flipped? Even at the top, though. It shouldn't be rotating. Well, of course they're gonna rotate. But they shouldn't be affected by the rotation matrix. Oh no. I could do with a mesh, but I don't have a mesh loader, so just something with correct tangents. So every other face, I guarantee you, it's the front face. Green, green. So these ones are 3x3. Then it did a weird thing. Let's do it the other way. It's getting towards the end of time. Really. Green pointing upwards. It's the same. This looks correct. Oh. You're kidding me. It was the other way. My tangent space was... Right. Oh, no. Okay, well, now I need to double check my... Here we go. Green is up. Purple is down. My red and my green are incorrect. Green is up. Hold on. So now it's all right. I need to multiply by the transpose. Also, well, I want to get this pause delta to this. Let's add the sphere in there. No. Just go touch this file. What's going to happen is that means it'll reset the rotation. Should be a way to reset it, to be honest, but that's... Okay. So that's correct. This face is correct. Red, blue, green, purple. Green, yellow, purple, green, purple. That's good. This guy. Green, red, darker green, purple. So everything is good in identity position so far. Which is purple, yellow, green, purple. They're good. Damn. This one, same purple, green, red, darker green. Yeah. Right. So that's all brilliant, basically. That's all totally correct. Zero point zero 0.01. So I'm going to go super slow-mo. Right, let's follow this face. The front face. So when the front face gets here, I'm going to check it. I mean, I've never gone into this level of detail before, but fun. Fun, but also distressing at the same time. Ah, I should have made that a bit quicker, but fine. Okay. So as we approach, we're approaching red and or unit X. Pause the delta time. Not quite. Pause the delta time. Right, here we go. So we've got green is up. We've got magenta. Not magenta. We've got purple. We have got correct. That looks correct to me. So this is correct. This face. Red, blue, green, purple. Yes. This face. Yellow, purple, green. It's all good. So they've survived a rotation. Single rotation. And everything is orientated correctly. So now we're going to wait here to get another face to come around. Should I make it faster? Only very slightly. Very gently. Very gently. As we wait for it to come around. Pretty aligned. Pause the time delta. Right, what are we saying? Red is on this side. Darker green. Down. All good. That's good. Purple. Yes. Yellow. Yes. Was I just mistaken before? Green, purple, red. It looks correct. So we've survived 2 rotations, right? 2 rotations. Now we get into... what have we got? 1, 2... We've only got 1 more to do. Oh, let's check the top. Yeah, red is pointing that way. Darker green pointing that way. Purpley pointing that way. And yellow pointing that way. Yes. Right, so then we just come around to the final one, or it could be as we return back and we rotate around with ever increasing rotation. Maybe. I don't know. Maybe it's something like that. Resume delta time. Watch as it comes around slowly. Purple is pointing that way, yellow is pointing that way, green is pointing up, purple is pointing down. Yes, 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 yes. Yes, 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 yeah. Maybe I looked at it and I was mistaken. The edges are a bit confusing. Let's check the top. Top. We've got purple on the inner, that on the outer. Red. Get in. It's got to be. Let's make it. No, it's too fast. Right, that is the cube. Done. Done, done, done. Let's have a look at it rotating. With my new slow camera as well. Oh, yeah. There we go. Perfect normals and perfect tangent space. Done for the cube. Now I've got this, the basis of that, then I know the math is correct for the transforming the normals and the tangents and doing the tangent space. So then what it's down to is the meshes themselves. So what what it would be, the example would be to then add. Hold on, I did hijack the geometry primitives sample to do this. But I can add say a sphere mesh. And some of them, there's not as many as you think because some of them they use the same code, just parameterized to make the different shapes. The cone was obviously the problem or one of the problems. What the hell? The sphere looks perfect now. Without me even touching anything. So, except for that black, the void. Am I doing something wrong? No, like this seems too good to be true. Hold on, let's go with this and let's just go and let's see the whole bunch of them. I think some of them ones that are like sphere curves, you know, they're kind of like they're quite procedural. I mean, these are actually aren't looking too bad. You know, I can't believe it. I don't know how this has happened. What's happening? Is it this is correct, right? I am debug tangent space. We output the normal and we bias into it was all along the TBN need to be multiplied by the transpose. And oh yeah, because it's when it's column they need to be column vectors. But the matrix is a row major. So I think that's a problem. The inside of the tubes look a bit wrong. I mean, these guys. I got this from, well, it's the original Utah teapot. It's not a very good mesh, the Bezier patches. So they're just garbage tangents actually. But well, I was gonna call it a day, but now I've been energized, and these look like obviously there's these bits. There's a little dud, a little bit of a dud tangent there. Is it? As we approach this bit, I mean these corners they're not too bad, but the corners were quite difficult. And oh, there's a seam. You can see the seam. How embarrassing. How embarrassing. But aside from a couple of bits, I mean, they're not like it's not a kill. It is a killer actually. I'll have to sort that out. But like these are well, actually, there's going to be subtle differences. I think where we need to flip the UVs. Or is that? I think because some of them were based on others, the things that might be wrong are. See, these actually, these are interesting. They like, do they invert? No, actually. I can't believe it. I really can't. That's correct. That's a stretched version. That's correct. But I feel like it was not working and everything was wrong. Right, the cone. Look at that. That is UVs are horrible, and oh, is that the actual cone? Is there a better cone? No. The cone, the cones of Dunshire are a problem. These inner like tubes, they're incorrect as well. I think I even did that. So these inner tube ones need sorting. These UVs aren't so nice. Teapot. There's minor bits, but wow. I am going to call it a day there, but that was pretty good. Tangent space normals. I'll clean up the rest. Um, and that leads on nicely to be able to do lighting on the material system. So that was my kind of transform world and construct tangent space, which is now done. I can add that into a function. I did have to use only a small bit of reference there from my previous code. I mean, I have done this stuff a million times by this point. I like doing the same things again and again. Um, I was working on executing direct in this sort of a bit quietly. I didn't do a stream for a while. It is quite draining, but I mean, when you get this, when you get pretty much working, I mean, I think the tangents are off on the torus, but when you get pretty much working code, what more can you ask for? Should we make them rotate? Can they? Yeah, they can. Let's get them back into their normal kind of. Oh, hold on. Is this the original cube? No. I'm gonna have to go through and check those subtle details, but like the main thing is the basis of them is correct. And that means I've got that code to have used for another day. And the secret was multiply by transpose. That was the thing that was causing. Oh, let's do that actually, just to see it go all wrong. Yeah. There we go. There's them all looking wrong, and I was like, this is gonna take forever. I'm gonna have to go through every single little thing. Ah, so roughly tangents. Need to double check these UV flipping things and so on. Those were the ones. That one was right. This one. Some of them we had to flip. That's correct. I mean, in the first place, did I even need to do any of that flipping? That is correct. That is correct. But these ones. Red. Yeah, red and green. This is wrong. Yeah, the cube is wrong, actually. The detail in it is wrong. Might be the same to be said for the others. So I think there probably is a bit more painstaking work. It looks probably better than it is. But the normals, the tangents look nice. Right. Right, that's it. I'm going. Bye.